In this video, I'm going to solve this second order constant coefficient homogeneous differential equation. And the equation in question is y double prime plus 3y prime is equal to 0 with initial conditions y of 0 is equal to 5 and y prime of 0 is equal to negative 3. This equation falls into the standard second order constant coefficient homogeneous differential equation, which has the following structure: a times y double prime plus b y prime plus cy is equal to 0. In our case, c is 0 because there is no y term. And we make the assumption that the solution to this differential equation is going to be of this format: y is equal to e to the power r t. Okay, and where r is a constant. This could be a real number or it could be a complex number. In this particular example, we are dealing with real numbers. So y prime is going to be r times e to the power rt, and y double prime is going to be r squared times e to the power rt. Now, if I take this value and plug in here, I get r squared e to the power rt plus 3 times y prime r e to the power rt is equal to 0. I could factor out e to the power rt times r squared plus 3r is equal to 0. Obviously, this is not going to be equal to 0, right? Then it must be the case that is equal to 0. If we factor out r, we are going to get r times r plus 3 is equal to 0. And by the way, this is the characteristic equation which we will solve in order to find the values of r. So r is going to be equal to 0 or r is going to be equal to negative 3. So my solution y1 is equal to e to the power 0t and y2 is equal to e to the power negative 3t. All right. So y to the power 0t, which is just 1, right? So the general solution is going to be y of t is equal to c1 y1 plus c2 y2 is equal to, so now c1 y1 is actually just 1, so I'm just going to put it there, plus c2 times y2 is e to the power negative 3t. So y prime of t is going to be negative 3 c2 e to the power negative 3t. The second condition is going to give me nothing but negative 3 c2. So I'm applying this is equal to negative 3, or c2 is equal to 1. Okay. So my c2 is 1. Then what is my c1? So to find c1, I have to just take this equation, and y of 0 is equal to 5. So c1 plus c2 is equal to 5. That gives me c1 is equal to 4 because c2 is equal to 1. So my solution is going to be y of t, okay, is equal to c1, which is 4, plus c2, which is 1, times e to the power negative 3t. And that should be the solution to this differential equation with initial condition y of 0 is equal to 5 and y prime of 0 is equal to negative 3. I hope that this discussion was helpful. Thank you very much.